We'll start off by the fluid delivery systems. For this particular demonstration, we're using the AirMix 15:1 EOS pump located in the back of this assembly here. We have one pump for the resin supply. We have one pump for the catalyst supply, and then another pump separate from those for the solvent supply. From there, the resin or the base material leaves the pump. It'll enter into an inline super filter, gold top AirMix regulator, and from the regulator into the resin circuit of the machine. Catalyst does the same thing, where it leaves the pump, enters an inline super filter. From the super filter, it enters a gold top regulator. Now for the catalyst side, we offer a standard gold top regulator and a pH gold top regulator for acid catalyst applications. And what that is it involves the replacement of the 304 stainless steel to 316 stainless steel. And a great way to test that quality of your stainless steel is by using a magnet, testing for magnetic draw to your stainless steel. 316 stainless steel will have 0 magnetic draw, whereas 304 stainless steel, you will feel a slight magnetic draw. The super filters will come standard as a number 6 size filter, unless otherwise requested at the point of purchase. And from there, the catalyst will leave the regulator, and we utilize a Teflon lined stainless steel braided hose for all catalyst applications that have pH in it. So the regulators and the filters are add-on accessories similar to what Bob had mentioned about the air solvent shop kit, the flush gun kit. These do not come standard with the Cyclomix Micro machine itself. They are add-ons. So going one step further, the resin material leaves the regulator and it enters our resin color change block. This machine is a 1+1, so we only have a valve here for one resin and the solvent for that resin. If this was a 3-color machine, there would simply be an additional valve here, a valve block here, and some additional controls in the software. From that point, we have an exit. The exit flange of the material will come out, travel up through a check valve, and the check valve is standard on all machines. And from that point, it goes into our flow meter. And these flow meters are going to be the same if your machine is a standard unit. If you have a pH unit, the catalyst flow meter is going to be a 316 stainless steel, and it comes with a slightly different design as far as the way that the gears rotate. Back to the resin side, once the material enters the flow meter, the teeth in the flow meter start to rotate, and our sensor picks up the counts. Now, there's something with the flow meter, there's something called the K factor. And the K factor for this machine is 0.24 cc's. What I'm referring to is the amount of material that passes through the flow meter per tooth, per pulse, that is being sent back to the controller. So for every 0.2 cc's or 0.24 cc's of material, we're getting a pulse. And the calibrations is what translates that into actual cc's for consumptions and ratio monitoring. Now the resin exits the flow meter and it enters a 3-way position valve, a 3-way manual valve. And it's important that the manual valve is pointing back towards the injection block. okay? Because the resin is continuously flowing with this machine. It's designed to where we have 100% flow of resin, and we inject small quantities of catalyst into that flow of resin, hence a percentage of catalyst injection. Shifting gears over to the catalyst circuit, we have our catalyst supply hose here and a solvent supply hose here for the catalyst. Most of the time, the solvents are compatible for each component, your resin and your catalyst. There are occasions where you need to have separate flushing solvents for each. So being the coating supplier that you are, you will automatically know this, and you won't have to go through some of the things that I've experienced. So the catalyst will leave the catalyst selection block, or the valve, travel through a check valve. From the check valve, we go into our catalyst flow meter. Now, if it's a standard machine with no pH, no acid in your catalyst, the machine is going to have interchangeable flow meters, meaning that the part number is going to be the same. But if it's a pH machine, the stainless steel is upgraded in the flow meter, and we also replace the bearing that the gears rotate on. The bearing changes from a ball bearing design to a carbide shaft design. And that's because we've found with the aggressiveness of most acids, it disintegrates and dissolves the ball bearings, and the flow meter is useless at that point. So from that point, we exit the flow meter and enter our VP6 catalyst injection valve. And throughout the course of the operation of the machine, this valve will open and close depending on our ratio and the flow rate that we're running. With this machine, your flow rate is going to be designated by the tip size that you're using through your AirMix Excite gun and your resin supply pressure to the machine. Now, with this particular unit, we're using a manual regulator to regulate our mixed material as well. I mentioned earlier the VP6 valve and the injection block. This point right here is where our resin and catalyst meet for the first time. So what we're doing is we're injecting the small quantities of that catalyst into the continuous flow of resin, and then from this block we enter a static mix tube. And this is outfitted with our pH unit, a 3-piece 316 stainless steel static mixer, and then from there we enter a manual low pressure airspray regulator, and then out to our F-Pro airspray gun. Any questions from anybody up until this point?
Oh, we're good.
Okay. From here, I'll cover a little bit about the theory of operation on this machine. In order for any of our Cyclomix line of equipment to work, including the PU3000, we require roughly 10 to 15% higher catalyst pressure over the resin pressure. And that again is to ensure that when we open to inject our catalyst, that we can overpower the resin and actually complete that injection accurately and crisply. That 10 to 15% value is a very rough value, and it's meant to be a great starting point for your installation. That's what I do based on my experience, 10 to 15% good starting point. And then once the system is up and running, you may see some ratio fluctuation here and there. And as you bring those pressures in closer to the 10 to 15, maybe 20, depending on certain viscosities, and differences in viscosities, you'll see that ratio will balance out and be more steady. If for some reason there's the need for additional static mixing, there is no reason why an additional static mixing kit could be added. That is perfectly fine. However, I have never experienced that in the 12 years of installing these machines. I'm not saying it doesn't happen, but the machine is capable of mixing at an accuracy level of plus or minus 1%. And that's because these valves are capable of opening and closing within a millisecond. So with that fast response time of the valve, we can ensure a very accurate and repeatable injection. And because of that, we've found that the three 8-inch pipes, when combined together, does a pretty adequate job of 99% of the coatings out there. So from that point, I think I'll go ahead and I'll turn the controller on. We have basically four different control options of how to navigate the menus and the inner workings of the controller. And then one other major thing that is very important for everybody who installs or services or even deals with the machine on a site basis is how to check the version of software that is in the machine. In order to check that, you use the factory supplied magnet, place it over the OK switch, and power the machine on. 2.82, version 2.82 is the software version that is currently loaded in this machine. And that's a great reference for troubleshooting if you have an existing customer where for some reason they're starting to have issues, or potentially they want to upgrade the software, because there are certain things that are offered now with the software that we did not offer 5-6 years ago, that make the machine more integratable and user-friendly for flatline application or certain automatic application. So that was how you check the software. Again, power on with the magnet over the OK, and you can see it's version 2.82. From there, we power on with main menu F1. F1 is our production menu. This is where we would select the OK. By placing the switch over the OK, we would start a loading sequence. And once that loading sequence is completed, the machine is designed to go into automatic production. So there's no need to re-enter or re-OK the machine. It's going to automatically enter production. But before we do that, we're going to want to go ahead and make sure that we have the correct parameters in the machine. And the parameters are accessed by going to F3 and hitting the OK button. Now if you see P1 is going to be our ratio. And again, we are a percentage of catalyst that is injected into the stream of resin. So let's see what ratio we're operating at right now. Okay, 8.3% of catalyst inject. I believe that's a 12-to-1 ratio if my math is correct. It's a very simple formula. If we're at a 12-to-1 ratio, we'll divide 1 over 12, and then we'll multiply that by 100, giving us the 8.3% catalyst inject. For instance, a 10-to-1 ratio would be a 10% catalyst inject. 2-to-1 would be a 50%. 4 to 1, 25%. And we also offer a really nice cheat sheet in our manual that just helps reinforce that, and we actually have the formula down on paper in our schematic documentation for the Cyclomix. Questions? Okay. So from there, we'll go ahead and change that ratio. Let's change it to 10 to 1. So we'll use the arrow up to select a 10 to 1 and simply hit the OK. It'll validate that it's OK and it accepts the recipe change, the parameter change. From there, we'll scroll up to P2. P2 is probably the most important parameter in the machine because it's going to be the one that prevents any damage from happening. This is our pot life. And as we're set up right now for a 30-minute pot life, that's a pretty quick pot life. So one piece of advice that I have in my experience is I've always set my pot life for half of what the technical data sheet says. I've just been very close to having to replace static mixers, supply hoses, and spray guns because of inaccurate data. So I always make it a habit to set my pot life for half of what the TDS recommends. We'll move on up to, well, first we'll go ahead and we'll hit the OK button, and that'll validate the 30 minutes. We'll scroll up to 3, and 3 is going to be our regeneration volume. Now, regeneration volume means two things, because when the machine is in a flushed state and we hit the OK button to enter production, we are going to be pulling from that P3 value of 680 cc's. And that's the amount of material that we calculate that it's going to take to fill the system, static mixer, hose, and gun, all with good 2K material. So that is our regeneration volume. The second important reason for this value is that this is going to be the value of material, the volume of material that we're going to need to spray in order for that 30-minute pot life to reset. So after we spray 680 cc's of paint, that 30-minute pot life will reset back to 30 no matter where it's at, and no one's the wiser. We just keep on spraying. Why it's so important is because if we don't have a large enough value here, and we're dealing with a very long hose or a very large diameter hose with a lot of material in it, we could start to see that cross-linking take place, that catalyzation take place in the hose, and what will happen is your flow rates will decrease and the velocity of your particle will increase, causing unacceptable coatings or appearance on your customer's parts. So we'll go ahead and leave that 680 cc's for our regeneration volume, and we'll move up to 4. What 4 is it's going to be our base or our resin flushing volume. This is the amount of solvent that we're going to use to flush the A circuit. And the nice thing about this machine is we have the ability to have different solvents for each material if it's so required. So the A solvent, we're going to start off with a volume of 500 cc's of material. And what's going to happen is when we trigger a flush to start, the material supply valves turn off. The material supply valves turn off, and our solvent supply valves will turn on. And they don't turn on together, but what's going to happen is the solvent valve would turn on, and it would flush out only our solvent or our resin or material supply circuit on the A side and out to the gun. We'll go ahead and accept that for now. We like that number. That's okay. Starting point. We'll scroll up to 5. And what 5 is going to be is the catalyst flushing volume. And you'll wonder, why is it half of P4? And the reason why it's half of P4 is because the way I recommend all of these machines to be set up for flushing purposes is to start with the catalyst first. So the machine is set up to where we would flush 250 cc's of catalyst and catalyst only, and it would automatically shut off and switch to the resin side immediately after. So we use the catalyst flush to clean the catalyst valve, the catalyst check valve, and the flow meter, and our VP6 valve. But once we get the material clean, once we get all of these components clean up here in the catalyst circuit, we don't need to keep cleaning them. So we set the machine up to switch over and flush the A side. So then from here we trigger and clean out the A valve stack, the check valve, the flow meter, our 3-way valve, and our injection block. And what I consider the P4, our base flushing volume, to be our main push. That's what I call it, is the main push, because I use just enough catalyst to clean the catalyst parts. It'll switch over and it'll do the A side, and from there I use that to clean the entire line out to the gun. So again, we'll okay the 500. We'll go up to P5, which is our catalyst flushing volume, and I'll okay that. And from there, we'll go to P6. P6 is going to be our tolerance. This is the mixing tolerance. We're allowed to go above and below our catalyst inject. So if we're at a 10% catalyst injection, our tolerance of 2.5% of that 10, not 100. So it's a lot tighter than people would presume just by glancing over the documentation. There's a little bit more to it than that, and you need to be cognizant of the fact that this is a percentage of your ratio, not out of 100. This would be our P7. P7 is going to be our basically our dry extract percentage, the how much solids we have in the coating. And the reason why we need to know how much solids we have in the coating is so that the controller can accurately log how much VOCs we're dispersing into the booth and ultimately into the atmosphere. It's depending on your customer, depending on where they're located. Some facilities are required to have annual permits. They have to qualify for certain permitting and requalify, and that's a continuing process. There are other parts of the country where they aren't concerned with permits at all, and so that value is not as critical. But I know on the West Coast and on the East Coast, it is. So it's very important that we accurately know what our percentage solids is and put that in as a parameter 7. Parameter 8 and parameter 9 are both going to be parameters that come preset from us, and they do not need to be changed unless you're performing a ratio check and the ratio check is off ratio. And if that is the case, I recommend simply replacing the flow meters. We have I believe our manual recommends every 6 months. If you're not performing calibrations and verifying that your meters aren't wearing out, then we recommend replacing them every 6 months to a year. And so again, I mentioned earlier the K factor. That 0.24 is actually 0.24 cc's of material per tooth that passes over the sensor. And that's how we can accurately log and meter mix each resin and catalyst. 10 is going to be our actual, so actually 10 is going to be the amount of time that we have before the machine needs to see pulses from the flow meter. Actually, so the way that these machines work is that there are 2 signals required for the controller to be happy. We have one of those signals is pulses from the A flow meter, and the other signal is a 24 volt on off coming from a flow switch in the back of the mix manifold. Now, on the side of the machine, we have an air inlet and an air outlet. The air inlet is identified by a sticker labeled R1. The air outlet is labeled R2. It's important that these are hooked up correctly because this air flow switch will not function properly without it being hooked up right. And the way that it works is the air in is going to a series of solenoid valves to control the pilot signals for our valves. And it's also going to be going to this air flow switch on the side of the controller. That air flow switch is then tied in to R2. And the R2, again, is air outlet. And that air outlet is set up to be our atomizing air to our spray gun. So while I said earlier, we have 2 signals that are required for the machine to be happy, more or less, in a production state. Pulses from the flow meter, the A flow meter, and a signal from that flow switch. It takes 5 CFM of air for that flow switch to close. And once that flow switch closes and we're receiving counts from the flow meter, we know that we're ready to monitor ratio, check for flow blockages, and all of that. So we're set up for 10 seconds here. This is in seconds. And what that is indicating is that your sprayers or your operators can't be, they cannot have atomizing air on for a period of 10 seconds without seeing pulses from the A flow meter. It will air out. It will air out. So we'll go ahead and leave that set up for 10 seconds right now. We'll validate that and move on to the next parameter. So this P11, I'm not going to hit the OK button here because it's going to start to simulate a mixing event. But this is our parameter for the ratio test. And it's nice because what it does is it's monitoring just the pulses and the air and the injection. It's not concerned about obviously ratio accuracy or any other parameters that could potentially fault out the machine. This is strictly looking for the proper values and flow rates from our flow meters. So we'll go up to P12 now, and P12 will be set at 100 from the factory. Now the 100 is referencing 100 pulses from the flow meter. You can increase or decrease the sensitivity by the larger number is going to decrease the sensitivity of this parameter, and the smaller number is going to increase the sensitivity of this parameter. And what we have this P12 for is in certain situations when this machine is being tied into an automatic system, certain automatic systems are not capable of delivering us a gun-on signal. By gun-on signal, I'm referring to that flow switch signal. What we do when we take this system from a manual application to an automatic application is we'll either recommend using the atomizing air from the machine, and if that's the case, that's great. But most of the time, these machines are going to be tied into a Scheffler flatline or Superficie or a catenaire, whatever the flatline might be. And when that's the case, there's definitely more than 1 or 2 guns being triggered at a time. And this atomizing air is probably not going to have enough volume to adequately atomize all 4 or 2 or 3 guns. So what is then done is this line is plugged, and we take the signal, the electrical signal from the airflow switch, and we tie that into a relay on the machine, thus simulating the open and closing of the airflow switch. Instead of using air to close the switch, we're using a relay from the flat line to close the switch. So P12, if there is the case where we don't have that signal, but this is not adequate, we have the ability to turn down and go to 0 and eliminate the need for 2 signals for the machine to operate. Not recommended, not recommended, not recommended, because what you're doing is ultimately relying on the resin and catalyst pressures to be set up correctly and the machine to automatically mix on proportion without any self-check. So with P12 being on at 100, we're self-checking. Every 100 pulses, it's self-checking, making sure all the parameters, everything is right. Now when we go to 0, we're disabling some of that self-check, and it's that trade-off where do you want it to tie into that machine that way? We don't recommend it, but it's a workaround. Leave this at 100 and always use the atomization air from the machine if at all possible. The other thing that we have available now with some of the newer software is password protect. And with how easy it is to access this parameter screen, sometimes even by mistake, the screen is accessed. We've developed a parameter screen to prevent that from happening. And so what we'll see is I'm going to escape, and I'm going to re-enter my F3 parameter screen. And because we went right to P1, I automatically know that there is not a password put in place for this particular controller. So we'll scroll down, and it's very simple. You hit the OK button to enter in that parameter menu, and then you simply scroll up, enter to move over, accept, and scroll over. So now I can't access any of my parameters without entering in that top secret code. And now I have access to my parameters like normal. So before I forget, I want to go and I want to set that back to 0 because just because. Okay, so let's go ahead and we'll scroll up and we'll go through all of our different menus now. Now that we've got the very important parameters out of the way, we can go ahead and check F4. F4 is going to be our consumption totals. So starts off with our A total. We have the ability to log log the A consumption, so we'll view that. This is in cc's, mind you, so 37,453 cc's. We will escape, scroll back down or up to the B component, 11,375. We can also scroll to the solvent. Now this solvent is going to be the solvent for A, 19,494. And then we also have a separate solvent for B, because keep in mind, if we're using two different flushing solvents, we're going to need to keep two different flushing solvent consumption logs. So we have solvent for B, 6,268. From there, we have the option of clearing or print. Now, this machine has the ability to attach and connect to a computer via a 9-pin serial port connector located here on the very bottom of the controller. However, it's probably more effective and faster for the customer to go in and manually look and see what our consumptions are. Simply because I don't think most computers have that 9-pin serial port connector anymore. We have also developed a data link networking system that is specific to this machine. And what that consists of is a 4-conductor telecom wire that is solid core telecom communication cable. And what it does is we use a simple node address system to designate from one machine to the next, and we're capable of connecting up to 30 machines on one of these networks. And that right there prevents anybody from having to come to the F4 menu and write down those values. I know that with a lot of our customers who do tend to have more than one of these machines, some of them in the dozens, some of them in the hundreds, they utilize that software and that networking capability from us. And it saves a lot of time on the floor and for their paint tenders or their operators or managers, whoever they designate with keeping the consumption totals, they get the software on their computer, and it ties into their network via a serial port adapter to an Ethernet adapter, and then that way they can pull in the data from each machine, dump it into a spreadsheet, and then put that on their network, and anybody who has access to that Excel spreadsheet can view the consumption totals for that week or month or however they divvy it up. So again, I'm going to go ahead and I'm going to select CLR for clearing purposes. I want to clear all of those consumption totals. And then we'll go ahead and make sure that they all did in fact, yes, they're all 0 now. Perfect. So from that point, we'll go and I want to show you my F2, the flushing menu. Anytime I'm bringing one of these machines online, I always execute a flush first. Because that's gonna make sure a bunch of things for me. You know, once I start the flushing sequence, I'm going to introduce solvent into my A circuit and my B circuit. That's going to ensure that I'm not having any leaks that I shouldn't be. And it's also going to ensure that my flow meters are functioning properly before I go ahead and introduce coating. You know, it's a lot easier to clean up solvent than it is paint. So, question? Oh, okay, sorry. So from this point, I'll hit the OK button here. We have the option of doing an A flush only. We have the option of doing an AB flush. And then we have the option of doing a BA flush. And this is where I mentioned earlier in the parameters menu that I always like to recommend the BA flush first because of the fact that it's more economical. We can clean the catalyst circuit out. The machine automatically changes and flushes the A side out, and then from that point on, we flush out to the entire hose and gun. So those are the 3 different flushing options that you have. And you wonder, well, why, if you recommend the BA flush so badly, why even offer the other flushes? And the reason why is because, you know, we have the A flush because if we're going to be running a 3+1 machine, a 3-color machine, and we're performing a color change, there's no need to flush the catalyst side out at all because we just need to clean the A side, load the new A side up, and resume our spray. And then why would we have an AB flush? And that's important because if our coating was demanded that we have a different flushing solvent for A versus catalyst, we would, depending on the coating, the volatility, sometimes one of these solvents might have a little bit of water in it, and that water might not be compatible with the catalyst or the resin. So we'll completely flush that side out and then shift over to the B. So again, depending on the coating and the requirements of your flushing solutions, an AB flush may be optimal, but again, 99% of the situations, in my experience, I find that the BA flush is going to be the perfect, the way we want to go. So from there, I am going to start a flushing sequence, and what it's going to do is it's going to trigger an audible alarm. The audible alarm is a simple, just a beeper located in the controller, and as the machine starts counting flow, it's going to, the audible tone will change. Now, I'm not sure how loud this is going to show up on the mic, so let's just go ahead and give it a shot. Not too bad. And I'm going to turn my atomization air off. And my timer is timing down. So we're on the B circuit right now. We're flushing the B side out. This valve is open. We're going through the flow meter, and so now that I know that the B flow meter is working, I'm okay with it. The gears are rotating. My valve, there's nothing clogged up in my valves. I feel a lot more comfortable about introducing catalyst to the system. We just shifted from FB to FA. As I said earlier, it does this automatically. My catalyst valves are now off, but my resin solvent valves are now on. Now I'll trigger the gun again, and we'll see it count down, indicating that we are completing the flush. And what that value is representing is a percentage of the flush completed. So we have 30% left to go, 20% left to go, 10%, under 10%. And from that point, all of the valves turn off automatically, and there is no more pressure out of the gun. It's just dissipating, dissipating, dissipating. As long as everything is good and clear, it's time for your customer to go home. This machine does not have an emergency override option like the Cyclomix Multi or the Cyclomix Expert come standard with. But those higher end machines have an option located on the mix manifold and or the fluid panel, where in the event of a power outage, you would press in a button that says emergency flush only. It overrides all of your piloted valves and pilots your solvent valve only. What the idea behind that is to ensure that we're going to have enough solvent in the system to where when power is restored, we're not going to have a catalyzation event and have to replace static mixers, possibly a regulator, a hose, and a gun. But however, we do not have an option for that with the Cyclomix Micro at this time. It would be we don't have any kind of standard solution as far as that's concerned.
We're not going to get a generator, huh?
Yeah, well, you know, it wouldn't be that difficult to integrate into the system. However, you know, in order for that, in order for the emergency override to even work, the customer needs to have an adequate supply of air in a holding tank. It's going to take more air than what is just in the lines to be able to perform that task. Yeah. So now that we performed the flush and verified we don't have any leaks downstream, our flow meters are working, the valves are working, I am going to exit the F2 and I am going to scroll down to F1. Now, when I start, and a lot of times on site, when you're starting one of these systems up for the first time, there's going to be a considerable amount of air in the line supplying to your catalyst valve. And one thing that we experience a lot of is the error 5. Error 5 is an error that's going to be displayed on the controller, and it's indicating that there are leaks with the VP6 valve. Now, because there's a lot of air in the line, these gears are behaving very erratically. So what we do, and sometimes it can be a little bit of a process, but it's you simply continue to reset and reset and reset and reset until that air balances out. And what is happening is we're compressing that air, and we're compressing it into the gear, the flow meters, and we're compressing it and pushing it through the VP6. And once it's through the VP6 and into the static mixer, it's fine, and that error 5 will go away. But you know, one thing I need to cover before we move into F1 are all of the different errors that this machine is going to produce throughout the course of production. There's 6 different faults that this thing is going to produce, and so what they are, error 1 is going to be our base or our resin flow meter blockage. That's going to occur anytime the operator is triggering atomizing air and the machine is not seeing pulses from the flow meter. It's also going to trigger an error 4 when the operator is doing this and it's not seeing any pulses. So error 1 and error 4 a lot of times happen consecutively together. It doesn't happen always, but a lot of times you'll see an error 1 followed by an error 4, and that is typical. The next error will be error 2, and what that is indicating is a catalyst flow meter blockage. The number one indicator, the number one troubleshooting technique for that is if you're getting error 2, make sure that you have an adequate pressure. Make sure that you have enough pressure to overcome that flow of resin and inject, because if those pressures are set up the same, then what's going to happen is that catalyst will just hit and deadhead against that flow of resin, simulating a blockage. And sometimes you'll get the error 2. Sometimes if you have just enough pressure to creep in, just enough catalyst to inject properly, you'll get an error 3. The error 3 is incorrect mixing ratio. Now, any one of those 3 faults, I recommend doing a flush and a reload. And if that fault comes back one more time, then in fact, I recommend performing some preventative maintenance or some service to your flow meters, or a valve. So from there, the error 3 is incorrect mixing ratio. And I must note on that as well, the machine display is going to update every time we inject catalyst. So every time this opens and closes, putting a new fresh amount of catalyst into our resin, we'll get a new value on our controller. The other thing to keep in mind is that in order for the machine to trigger an error 3, it needs to see 3 consecutive injections outside of our tolerance. So if we have that tolerance at 2.5% of 10, and we see injection of 11, followed by a 9, then a 12, it's going to fault because we are outside of that mixing tolerance and potentially going to be spraying something that will not cure or meet appearance requirements. So from that point on, we'll move up to error 4. I touched on error 4 a little bit, but error 4 is when the operators are triggering atomizing air and the machine is not seeing counts from the flow meter. This is one of the big learning curve things with this machine over some of our competitors' machines, and even over a hot potting or hand mixing solution. Whereas a lot of places will like to, you know, they got some parts coming down the conveyor and there's a little bit of dust on it, so they're gonna clean it off or dry it off before they spray it. And they can't do that with this machine because they will run the risk of those nuisance faults being the error 4. So from there we go to error 5. Now error 5 is going to be where we see pulses from the catalyst flow meter when we're not supposed to. So that's going to tell us that the valve is leaking here. Now that is going to be your most common error when, or fix, basically. When you see an error 5 and it's reoccurring, and you know that there are no more air in the system and the system's been running or what have you, and you start getting error 5s, that's telling you that there might be some catalyst seeping past this VP6 valve. And what it's doing, what the core of the machine is doing right there is the catalyst flow meter should not be seeing any pulses if the output for this VP6 valve is not on. That's something that's coded with the machine. So the only time this thing should be seeing pulses from the catalyst meter is if this VP6 valve is active. And the sixth and final error is error 6. Now, error 6 was something that was added recently within the past probably 6 years. And what error 6 does is it forces the operators to use our atomization air. Because on the very early machines, if we were not using the atomization air, if this was not being used, the controller would not know that it's in production mode. One of the things that we've learned throughout the course of the history of the machine, and that's why we integrated error 6, because it forces the use of the airflow switch, thus forcing the machine to monitor ratio when we're in production. That is the last of the error codes, error 1, 2, 3, 4, 5, and 6. From that point, I'll go ahead and hit the OK button here, and it's going to give us a similar audible alarm as to when we were flushing. So here we go. And during a load, I don't recommend having the atomization air on or the tip in the gun if it's an air mix tip. So I'm triggering the gun into the bucket of liquid, and you can see that we're counting down, performing our production fill or our prime. And the other thing that's occurring is our catalyst is being injected, and you can see that it's happening at a very fast rate. This valve is opening and closing at an extreme rate of speed. And you can see as the system and as the lines out to the gun become filled, the flow rate has gone down a little bit, and it's taking longer to flow and to run. And that's common when machine is pushing out the solvent and loading in your 2K. So now what had happened here is the machine went into automatic production, and it's at this point where your customer would replace the air cap and tip on the gun, make sure the nozzle is clean, everything is free of any debris or dried paint or make sure that it's very clean. And then we have to turn our atomization air back on because we are in production. So what I'll do is I'm going to show you what will happen if the operator or the sprayer sprays without having the atomization air on. Error 6, right away. Machine picked up those 100 pulses really fast. We're going to hit the OK. And now what I'm going to do is I'm just going to turn on a little bit of atomization air, just enough. 5 CFM is all that's required. And I'm going to put the machine back into production. I will spray into the booth for a moment of time so you can see the machine operate. So you can see that that last catalyst injection, we are 1/10 shy of meeting our desired ratio. And we'll spray again here. And the next catalyst injection, the machine automatically compensated for that, and we're right back on ratio. Okay, then what I'll do is I will show you what'll happen if we trigger just the atomization air. Count to 10. Air 1, because that airflow switch closed down, gave one of those feedback signals to the controller, but in fact the flow meter was not spinning. Obviously I was not spraying, the gears were not turning. It thinks that there is a blockage in the flow meter. The Air 2 is going to be a little bit harder to reproduce, but what I would like to do right now is I want to show you guys how the resin pressure and the catalyst pressure influence our rate of injection. So it's a 6mm Allen wrench to make the adjustments on our gold top air mix regulators. So what I'm going to do is I'm going to go back into production, and what I will do is I am going to increase my resin pressure to the point to where you will see the catalyst injection take longer. If you remember, our catalyst injection is taking place pretty quickly. And as I increase my resin pressure, my balance between the two is closer. The ratio is closer between my pressure here and my pressure here. Now you can see that, in fact, my catalyst valve never closed. And we should see a fault. So it just so happens that it's making it and because it keeps bouncing back, it hasn't faulted yet. As I said, producing an Air 2 when you want to can be difficult sometimes, as well as trying to produce an Air 3. If it's supposed to, it should be faulting right now, to be quite honest. So then one other error that I can produce for you is going to be the error 5. And like I said, error 5 is going to be where the catalyst flow meter is picking up pulses when the VP6 valve is not energized. So I will pulse this simply by moving these back and forth. Error 5. So error 5, we saw pulses and counts on the catalyst side when we shouldn't have. Faulted us out. Now, one other thing to be aware of is the 25-pin cable that connects the fluid manifold to the control manifold or the control panel is simply a 25-pin printer cable, and the standard length is 1 meter, about 2 point, what is it, Bob? 2 point something meters. It's about 6 feet. And we also offer another one out of our catalog that is about 18 feet. And that is the only communication cable between the controller and the Cyclomix Micro fluid panel. The fluid panel is completely stainless steel. The resin side is going to come with 304 stainless steel. And on a standard machine, the catalyst side is 304 stainless. But when we upgrade to a pH acid catalyst model, the CTM valve, check valve, flow meter, and the VP6 valve are all upgraded to the higher level 316 stainless steel. And there are 2 add-ons that I would really like to talk a little bit further about. One of which is the air solvent chop kit. We've done some studies here in the lab, and we have seen solvent savings of up to 50% by incorporating an air solvent chop kit. 50% solvent savings. For companies that are doing like a 3+1 machine, potentially running all 3 colors throughout the course of one shift, I strongly recommend that air solvent chop kit as an add-on because it's going to save them money in solvent waste and consumption. And it's also going to save them money in time because it is extremely effective when it comes to cleaning 2K. What the air does and what the solvent does is when you combine those two at a high pressure, it creates a scrubbing effect. And if you were to see it in a clear hose, you would see exactly what I'm talking about. It actually looks like there's bubbles in the solvent, but what's happening is that solvent compresses the air and that creates a scrubbing effect. That is how we're able to reduce solvent consumption up to 50% in those flushing situations. The other add-on that I would really recommend, is the regulators. You know, the regulators are, in my opinion, definite requirement to ensure the accuracy and the robustness of the machine. Number one, it comes with a great filtration system. These filters are very economical as far as there's very low volume material in these filters. So they're efficient to clean, efficient to fill and use. And you know, with a lot of these systems, taking shortcuts might look great on paper, but really we've seen the big benefit of having independent supply regulators for each micro. Taking it a step further is going to be an outbound fluid regulator. Now the outbound fluid regulator is something that we do here in the lab just to completely lock in and validate flow rates, because when we do a test here in the lab, we want to make sure that our team is going to be able to implement and execute in the field as closely as possible to what we've validated here. Now, One thing about having a regulator on your mixed material outlet is it could work against you to some regards, as far as if you're regulating down during a load or a flush, it's going to take longer. So that's one other thing to be aware of, is if you have a manual regulator on your mixed material to your applicator, your spray gun, when you do a load, open it up because it's going to load faster. And then when you're doing a flush, open it up because then it's going to flush faster. Obviously, when you're ready to go into production, you'll have a optimal, pressure setting that you'll want to adjust the regulator to, and then from that point, you'll have a very consistent and steady, repeatable spray pattern, regardless of the applicator.